A very good morning. A very good morning to one and all gathered here. I'm very pleased to be here today for the opening of the webinar titled Solar, a definite source for lighting the future world. Foremost, I would like to thank the Almighty and invoke His presence throughout this webinar. I welcome Professor Rajan, Senior Lecturer of Mahsa University. Professor Rajan graduated from GCT Tirunelveli and holds his Master's in Power Electronics. His area of expertise and research includes renewable energy sources and in particular solar. He published various papers in international and national journals and has also attended many international conferences. I'm also proud and happy that I've worked under his guidance. We welcome you, sir, on behalf of that group of institutions and Mahsa Engineering College. I welcome all the participants, faculty members, and my dear students for this webinar. Thank you. I now hand over the session to Professor Rajan, sir.
Thank you, ma'am. Very good morning to one and all present here.
Good morning, sir. Good morning.
First of all, I would like to thank the organizing committee, friends, and St. Mother Teresa Engineering College. Also, I thank Mahsa University for being here. And today, our topic is a solar, a definite source for lighting future world. Actually, this is a very good topic and reasonable topic. Nowadays, we are struggling to get the electrical power. Why? Since the demand increases. Moreover, the fossil fuels like petroleum products, natural gases, and coal. These are fossil fuels. The existence of these fossil fuels diminishing in nature. In future, definitely they will be vanished. So we have to go for alternate energy sources like renewable energy sources. Renewable energy sources, there are different type of renewable energy sources available. Wind power, geothermal, tide, wave energy, and solar. So I am very much interested in solar power plants. Solar actually abundant in nature, free of cost. The sun never ends. Always we are getting the solar power throughout the world. So it is a very good choice for us. And moreover, lot of advantages in solar power plant. Due to the advantages, in future, world believes in solar power plants. Definitely, it is a very good source for enlightening our world in future. No other secondary thought. Okay, power generation. So as I said, we have renewable energy sources and non-renewable energy sources. Solar, wind, hydro, tidal, geothermal, and biomass are some of the renewable energy sources. So I have selected the solar for my research. And non-renewable energy sources, fossil fuels, petroleum products, natural gas, and coal. These are carbon contents. So carbon is the main element in fossil fuels. These fossil fuels contaminating the environment. So environment pollution. It created pollution in the land, water, everywhere. So we have to avoid this kind of, but we cannot avoid. But in future, definitely, we can go for renewable energy sources. Fossil fuels, by burning the fossil fuels, it causes air, water, and land pollution. Extracting the process of fossil fuels can produce toxic gases to the environment that affects our environment. Ozone layers gets affected due to the fossil fuels only. They also release a lot of carbon dioxide into atmosphere, causing depletion of ozone layer and ultimately creates the global warming. Actually, this pandemic situation reduces the global warming, but unfortunately, the human beings are affected due to the COVID-19. Renewable energy sources, actually, what is a renewable energy source means? They won't run out, including wind, sun, waves, and tides. Why do we need renewable energy? Most of the electricity we use in UK comes from non-renewable energy sources, such as coal and gas. But these fossil fuels are running out in future. So burning them to provide energy also release gases that contribute to climate changes. Renewable energy don't run out or pollute the environment. Why don't we get all our electricity from renewable energy? It is important to have a mix of energy sources. So if one fails, another can be used. Also, many renewable energies are still being developed. In future, solar, wind. So wind energy, giant machines called wind turbines can be used to make electricity. In our area, Arloimuli, Kayathar, so near Sangramgoil area, Coimbatore, Tenkasi. So in this area, we are having lot of windmills for power generation. So you can concentrate on developing the wind blade design, turbine designs in those things, and you can install mini wind energy also, wind power plants also you can install. Then hydroelectric energy. Hydroelectric energy means energy from moving water. So we are having the Papanasam, Manimuttar dams for generating the hydroelectric power plants. So you can plan for many hydroelectric power plant. We are lagging in many hydroelectric power plants. Biomass energy. Biomass is plant and animal matter. Example, wood, straw, sewage, and waste food, or trees grown for fuel. We can burn biomass to produce heat and electricity. So you can concentrate on biomass energy development also. Hydrogen fuel cells make clean energy electricity from hydrogen gas. So you can produce the hydrogen gas from microorganisms. You can develop microbial fuel cells. In the microbial fuel cells, with the help of the bacteria, we can generate the electricity. That is the emerging trend nowadays. Geothermal energy, natural heat of the earth. Geothermal power stations use heat from deep underground to generate electricity. Wave energy and tide energy. So from the sea, tides and waves, we can generate the electricity. And finally, the solar. Solar power plants are, we can generate the electricity from the solar lights. So solar light energy can be converted to electricity. So from the lights, we can produce the photons the photons hits the solar cells, solar panels to convert it into electricity. Actually, we are getting the direct current, DC quantity we are getting from the solar power plants. Why we should go for solar? Solar actually fuel, there is sunlight. Sunlight is free and abundant, it never ends. Throughout our life we are getting the solar, so we can go for solar, best alternate for energy generation. Moreover, it's pollution free also, it will not contaminate our environment, reduces your electricity bill. So you can go for standalone systems in our houses for generating the electricity. If your house is far away from the grid, then you can go for standalone system, or off grid, that is off grid system you can go. But you have to use batteries and inverters. Then low maintenance cost, solar power plant, low maintenance cost, not like our thermal power stations. It is less maintenance cost, wide range of applications, diverse applications. You can go for the photovoltaics. In the water also, you can use the power panels. Then garments, in the garments also we can use the solar cells to generate less electricity actually. We are using the solar power panels for energizing your batteries, satellite batteries. For that purpose, you can develop the solar panels. Decrease in prices of battery nowadays, actually, the battery prices and solar panel prices decreasing. That results in more affordable off-grid electric systems. So we can say that solar is a promising future. So actually, it capturing the sunlight and generate electrical power, and it is the solar panels made up of photovoltaic cells that capture sunlight particles called photons, using semiconductor materials known as silicon. So silicon is the material to make the photovoltaic cells, solar panels. The PV cells then convert the photons into usable DC electricity, direct current. But in our houses, we are using the AC, isn't it? So the DC can be converted to AC with the help of inverter, different type of inverters available. So inverter convert DC to AC and given to your electrical appliances. So see, this is very simple. The concepts are very simple, not much complicated. The solar cell to solar array, actually different terminologies. Solar cell means the miniature, the minimum cell that can produce up to half voltage. The number of cells connected in series to produce voltage and form a module, that is module. Module means it produces 50 volts, 5 amperes. Number of modules can be connected in series. Here, number of modules connected in series to form a string. So 200 volts, it can produce 5 amperes. The number of strings are connected to form array. The array can produce up to 5 kilowatts. So this is the difference between cell, module, string and arrays. Now, there are different type of solar systems. Solar on-grid system, solar off-grid system, solar hybrid grid system. Actually, off-grid or standalone system, we can easily design. So today I'll discuss some sizing of your solar mini power plant for your beautiful house. Some small, very simple only, not much complicated. So you can design for solar power plant for your house. That is said to be standalone system or off-grid system. Solar on-grid system. So this is sun. The sun rays fall into your solar panels. The solar panels get the photons from sun energy and convert into DC. So the DC quantity current is given to your inverters through some switches, disconnect switches. Why we are connecting the disconnect switches means if the current exceeds the limits, it has to open. So for that purpose, disconnect switches are used. And DC is given to your inverter. Inverter naturally converts direct quantity to alternating quantity AC. So here AC switches we have to use, and that AC is given to your PV generation meters. It will measure how much energy is generated, and that one given to main fuse box, then to your houses. So you have to we can give the electricity to houses like this. If we are not using any energy, then we can export to EB, electricity board. We can export through utility meter, net metering. We can say net meter, utility meter. This one measures how much energy you export to EB. So that one it calculates daily and monthly. If you export some sufficient amount of energy means they will pay for the electricity which is exported to EB. Or otherwise, if sometimes during night time, if your solar panel does not, so naturally sun will not be in night, isn't it? So you can utilize the power from electricity board. So that for that the EB will put bills for how much energy you utilize from electricity board. So that purpose utility meter. So if you get the utility meter, then we can export the power to EB as well as import power from EB. So this one combination of these two, standalone as well as the EB. So this is called solar on-grid system. Off-grid system actually is standalone system. So solar panel gives energy to your solar charge controller. So we are using the solar charge controller for regulating the power to batteries as well as it stop power fed to your solar panel. So it won't permit power to solar panel, only it permits solar from solar panel to batteries. So for that purpose, we are using the solar charge controllers. And moreover, the solar charge controller takes caring of the battery charging and battery discharging. Okay. The DC is also given to your inverter. The inverter converts DC to AC. So in the load side, we are using the AC loads. So the AC loads utilize your AC power, which is given by your inverters. And also we can use DC loads. So DC lights can be used here. This one DC directly we can give the DC to your DC loads. So here there is no EB. There is no EB. So this is off-grid system. And solar hybrid system. Solar hybrid is actually the combination of on-grid and off-grid. So here the sun emits energy and the photons hits your solar panel. So solar panel produces the electricity and given to your solar charge controller. And solar charge controller gives energy to this battery bank. So battery is a energy storage device. It stores the energy, and it can give energy to your inverters. So DC is given to inverter. Naturally, DC is converted to AC by inverter, and it is given to your here we are giving to electricity board, EB grid side, and also we can give to your house, home appliances also. So in hybrid system, we can give the energy to grid as well as house. Energy to grid as well as house. So for these two purpose, combination of two, this is called, that's why it's called hybrids. Combination of house as well as grid. In the on grid, only connected to grid, not connect to house. Off grid, only connect to house, not to grid. But hybrid means it is connected to house as well as grid. So this is called solar hybrid system. So whichever design you want, you can go for the solar, either on grid or off grid, or combination of on grid and off grid. So nowadays actually the battery and panel prices are decreasing. In future it will decrease further, since lot of countries they are developing the solar panels for generating the electricity. So battery as well as solar panel prices decreasing. Moreover, our government also giving subsidy for house. So you can go for off grid, means they can give subsidy. Okay, so you can go for MNRE website. So in the MNRE website, they can give what are the rules to get the subsidy for your house, not for company's purpose, only housing purpose. We can install the solar power plant. So subsidies will be given by government. Okay. And general factors related with the solar panel. So there are different factors actually. How to increase the solar power protection? That one, some important factors affecting the improvement of your power generation. For example, solar tracker. So tracker can move the solar panel from left to right or top to bottom, like that, based on your position to extract more power, more light energy from sun. So for that you need to know the location of your place, geographically. Okay, so if you know the orientations, then you can place the solar tracker or place your solar panel accordingly. So that is one factor. Then inverter, actually string inverters generally we are using, but if you are using string inverters, some disadvantage. Shading creates more problem to our, that more problem is actually it is reducing the efficiency. Since the solar panels are connected in series, so shading of one solar panel affects the efficiency of all the solar panels connected in series with that affected solar panel, that is shaded solar panel. So due to that one, the efficiency decreases from 90 to 40% due to shading of one solar panel. So how to avoid this kind of problem? That is one. And temperature. Actually, if the temperature is more, its efficiency will be reducing. Since your solar panel gets more heated, so we have to reduce the temperature, surrounding temperature. How to reduce this surrounding temperature? That one you can go for agrivoltaics and photovoltaics, so that we can reduce the temperature. Okay, so some factors actually. So let us see one by one. Net metering concept, as I told earlier, net metering concept actually, the solar panel generates the electricity. If you are in the daytime, if you are going to office, colleges, then you will not utilize the electricity. So that electricity generated by your solar panel can directly export to your EB, electricity board. Then the net metering calculates the energy which export to your EB. And afterwards, evening time, there is no sunlight. So you can import electricity from EB. So that also calculated with the help of net meter. Then it will how much export, how much import. Remaining, if any remaining is there, means we can get amount from EB. If we are utilizing more, then we have to pay to electricity board. Okay, so that is the net metering concept. Then solar trackers. Actually, solar trackers mounted on pole mounted. Then angle of the panels from two trackers actually, single axis tracker and double axis tracker. Single axis tracker we can move from left to right. Double axis actually adjusts both angle of your solar panel as well as left to right. That is done by solar trackers. So you can go for single axis or double axis based on our budget. So budget is very important, isn't it? So performance benefit of between 35 to 50%. We can increase the efficiency. So most installers report a performance benefit of around 30% for single axis trackers. So if you're using single axis tracker, you'll get 30% better performance compared to fixed solar panels. So 30% depends upon the companies. It may be either plus or minus 5%. And if you are using double axis trackers, then performance is 40%. That also plus or minus 5%, depends upon what company you are using. Then automatically orient the solar panels towards the sun to maximize their effectiveness. Then additional investment, actually solar tracker, if you think it is an additional investment, means that depends upon our thinking and our budget only. Okay, some may think this is whether cost effective or not. Solar trackers work using sensors and electric motors or hydraulics. So you can use sensors for sensing the light where light is there. Then electric motors, with the help of electric motors also, you can tilt the solar panel. That design also you can make. Then hydraulics, with the help of hydraulic movement, you can move the solar trackers. The ultimate aim is to extract more power. Okay, so these things consume some small amount of electricity. Okay, for electric motors like that. The amount of energy they consume is a small fraction of additional energy they capture from the sun rays. Then some professional tools are available for obstacle analysis. So the solar scientists use some professional tools for obstacle analysis. The solar pathfinder is surprisingly effective as it can be easily moved around in order to find the best location for solar panel. So solar pathfinder is available to identify which location is best to give more electricity. And many professional solar installers still use a solar pathfinder for quick fixes, more expensive and advanced electronic equipment to provide a more detailed analysis. Then electronic systems such as GPS, tilt switches and accelerometers also used for this purpose for tracking the solar light. It is work electronically and they are expensive to buy or rent on a daily basis actually. Then cable thickness. How much cable thickness can erect for your based on your design. Actually PV system DC voltage is maybe 12 volt, 24 volt or 48 volt is these are the standard values, 12 volt, 24 and 40. For the same wattage, much high currents are involved in the PV systems, much current, high current. So 20 meter is the length of cable between panel, solar panel and charge controller. For example, if you the distance between the solar panel and solar charge controller 20 meter length of cable is required, then how it affects actually we can go if you go for 1.5 square mm cable size, then it has resistance 0.012 ohms per meter of wire length. So 20 meter means the resistance 0.24 ohms for 1.5 square mm 20 meter length. So for 24 volt 10 amps current flows in the wire, then how much voltage drop for cable between solar panel and solar charge controller, how much voltage drop exactly we cannot get all the 24 volt, some drop may be there, isn't it? So how much by Ohm's law if you calculate the voltage drop 10 times 0.24 2.4, actually this is 10% voltage drop, so this cannot be accepted, that is more voltage drop. This one 2.4 voltage drop is more, so we cannot accept, so we have to go for alternate. So instead of 1.5 square mm we can use 6 square mm. If you are using 6 square mm, its resistance 0.003 ohm per meter, so resistance is less for 6 square millimeter, so resistance is 0.006 ohm total resistance, therefore voltage drop 0.6 volt only. So but previous case 2.4, this is just 0.6 volt only, 2.5% voltage drop, so this may be acceptable for 24 volt system. So for a 24 volt system you can go for 6 square mm cable for 20 meter length, so less drop. Then MNRE website they have given IEC standard for solar systems, so solar charge controllers, power condition, MPPT and protections, storage batteries, cables, switches, junction boxes, everything they have given standard format, standard description for all these components, what are the testings required. So based on that we have to do this type of testings, then we can install your power plants. So these are some standard formats. Now temperature, solar cells perform better in cold rather than in hot climates, since it absorbs the sunlight only. Okay, so better performance in cold compared to hot climate. Very hot means it performance derate. For each degree rise in temperature above 25 degrees Celsius, its efficiency decreases, 0.25% decreases for amorphous cells and 0.4 to 0.5 for crystalline cells. So in hot summer, if the temperature go easily up to 70 degrees Celsius or more, means its efficiency reduces drastically. So for example, 100-watt panel will produce only 75 watt in May or June in most parts of India, where temperature reaches 45 degrees Celsius and beyond in summer, and electricity demand is high. Actually, during summer, electricity demand is high, but due to temperature rise 45 degrees Celsius, its efficiency reduces. Then how to rectify this kind of problem? How to rectify? So we can go for photovoltaics, agrivoltaics. So here in the ground we are growing the plants. So this will reduce the ambient temperature. Therefore, the solar panels give somewhat better performance compared to the land without plants. So between May and July of 2019, solar panels over crop plants were 3% more efficient compared to without crop plants. Okay, so without plants, its efficiency is less, but with plants, the efficiency increased by 3%. So for small system to large system, you can calculate. So 3% more efficient compared to this one. And this one, next one is photovoltaics. In the water, we can install the PV panels. This is floating in the water. So the water decreases its temperature. Moreover, the water will not evaporate. So double purpose. Then next factor is shading. The cells within a panel are normally wired in series, and the shaded cells affect the current flow of the whole panel. Okay, so we have to plan accordingly for shading. So how to avoid this kind of problem? If one panel is shaded, the other panels connected in series also gets affected, and its efficiency reduced by 50%. If actually your solar plant produces 90% efficiency, means due to shading of one solar panel reduces its efficiency from 90% to 40% for all the solar panels which are connected in series with your shaded solar panel. And other drawbacks, what are the other drawbacks of string inverters? Actually, we are using the string inverters. Some other drawbacks, actually, same number of solar panels you have to connect, same number of solar panels. Then the angle of solar panels also should be same, and type of solar panels also should be same types. Actually, different type of solar panels, from basically monocrystalline, polycrystalline, thin film technology. These are fundamental things. We have to use same type of monocrystalline, means we have to install all the panels are monocrystalline only. Okay, so in these three, another one is emergency condition. The solar panel will not shut down, but your grid is shut down, but solar panel still generates the electricity. It will, in this condition, cable from roof to inverter will still be the high tension. So high tension, and your cables will get affected. Solar panel also still working unnecessarily, since your grid is not there, isn't it? So how to overcome this kind of problems? What is the solution? Two solutions. The scientists, researchers invented two methods. What are they? Means microinverters. So we can go for microinverters instead of string inverter. In the olden days, previously we are using string inverters. Now we are going slowly to microinverters. And another option is power optimizers. So these two things avoid those problems. Microinverters. So microinverters actually connected below every solar panels. Every solar panels below the microinverters are connected. So shading of one solar panel will not affect other solar panels, since each solar panel having separate microinverters. So it will not affect other solar panels. See? And also DC power optimizers. So if you're using DC power optimizers, that also install in all the solar panels. So shading one solar panel will not affect other solar panels. See here, so this one 40%. Other solar panels still 90%. So due to microinverters as well as DC power optimizers. Okay, so only the shaded due to bird, that particular panel only efficiency reduced to 40%. Other panels still 90% efficiency. Comparison between string inverters and microinverters. Actually, string inverters nowadays we are using in future also more developments in microinverters. Entire system affected by one module. All modules controlled independently in microinverters, susceptible to soiling, shading, and module defects. But this is resilient to environmental factors. And third one is leaf shading reduces its percentage to half. Leaf shading or bird shading, say bird is sitting in one panel and other panels reduced to 40% due to compared to 90%. It is other panels connected in series with that shaded one effect reduced to 40%. But you are using micro inverters, other panels will not get affected 90%, still 90%, but the shaded one only 40%. And another very good benefit of microinverters. So you can plan for solar panel installation. Actually, initially when couples are there, initially you need only 675 kilowatt hour. Then you can design your solar panel accordingly. After some time, with the coming of your children, the power usage increased to 738. So you can extend your panels with the help of microinverters. Since each panel consists of separate microinverters, so separately we have the microinverter, so we can easily extend our solar panels. And after some time you are using some electrical devices, so you can extend 998. After that 1657. Then if you are using electric car in future, actually most grown countries go for the electric cars. In future, India also we are going for electric vehicles. A lot of research works are going on to develop the hybrid electric vehicles. So if you are going for electric vehicles, means 1926 kilowatt hour usage. So the usage increases, usage of electricity increases. With the help of microinverters, we can extend our solar panel accordingly based on our requirement. But if you are using string inverters, we cannot do like this. Then solar charge controller. Solar charge controller uses, actually, what is the benefit of solar charge controller? Means low voltage protection. So if your battery go beyond certain limit, then solar charge controller enables and gives energy to your battery for battery charging. And over voltage protection. If your battery charges beyond your limit, for example 24 volt battery, means if the voltage beyond 24 volt means the solar charge controller stop the feeding of energy to your battery. So then battery cutoff circuit, backup current protection, over discharge protection. So the battery should not over discharge. So for this benefits, we are using the solar charge controllers actually. A lot of research works are going on still developing the solar charge controller. Basically, PWM, pulse width modulated solar charge controller, and MPPT, maximum power point tracking charge controllers are available. Some places we can go for PWM. The small mini power plants means you can go for PWM, and mega size then you can have to go for MPPT. Solar actually. In times of rain or rainy season or heavy clouded days, a situation may occur when batteries remain in the state of less than full charge. This would further pull down the panel voltage, thus degrading the output further. Then what is the solution? So MPPT is the only solution. So if you go for MPPT, we can avoid those things. Charge control comes into picture. It tries keeping the panel at its maximum voltage and simultaneously produces the voltage required by the battery. So required voltage only given to your battery. Since solar panel the solar panel rating is 12 volt, it can generate up to 16 volt. We cannot give all the 16 volt to your 12 volt battery. So we have to regulate the voltage. So for regulating the voltage, we are using the maximum power point tracking controller, MPPT charge controller, that regulate your voltage to battery. Okay. And MPPT controller suitable for cloudy, cold condition, far from equator, winter time, and it's because the 25 to 30% more power can be generated with the help of MPPT controllers. Then solar orientation in India. Actually, India is located in the northern hemisphere, but closer to the equator between latitudes 6 degree and 36 degree in north. The longitude boundaries are 68 degree and 98 degree east. So 98 degree east, and in the north 37.6 north, that is 36 north, and this one 6.45, this one west 69. Okay, here 8.4. In order to get the most from solar panels, they must point in the direction that captures most sunlight. In India, as anywhere in the northern hemisphere, solar panels should face southwards. So we have to install the solar panels in India southwards to get more power. Then panel orientation, how to orient your panel. The horizontal tilt of panels may be adjusted 4 times a year at the latitude, angle in spring and autumn, then latitude minus 15 degrees in summer, and latitude plus 15 degree in winter. Okay. So like this, latitude, your latitude minus 15 degree in summer and latitude plus 15 degree in winter side. Like that, you can change the panel orientation. One can choose the angle depending upon when the power requirement is greatest. Adjust angle twice a year for summer and winter seasons. The best time to adjust for summer angle is mid of March. Mid of March, you can adjust the summer angle, and mid of September for winter angle. So for winter means mid of September you can adjust the angle. Following the 15 plus or minus rule. For Mumbai, Delhi, you can set the panel angles as follows. For Mumbai means latitude 18 degree 55 inch for north. Summer angle is 3 degree and winter angle is 33 degree. Similarly for Delhi, the summer angle is 13 and winter angle is 43 degrees. So some methods they have given for orientation of your solar panel. Actually, quick and easy method. Take your latitude and add 15 degrees for the winter. Winter means 15 degree add. Summer means subtract 15 degrees. For example, if your latitude is 40 degrees, the angle you have want to tilt your angles in the winter 40 plus 15. So add 15 degrees for winter. So 40 plus 15, 55 degrees. So your solar panel should be 55 degrees. In summer, 40 minus 15, 25 degrees you have to place. Then method 2A, the better way for winter. In the winter month, when there is less sun, take your latitude, multiply it by 0.9 and then add 29 degrees. For example, if your latitude is 40 degrees, the angle you want to tilt your panel winter is 40 times 0.9 plus 29 degrees. That is 65 degrees. This is for winter. This is above 10 degrees steeper than quick and easy way. It's more effective because you want your panels to be directly facing the sun at midday during those short winter days. So this is one method, better way. And next method for summer, better way for summer. Takes your latitude, multiply it by 0.9 and subtract 23.5. So you have to subtract for summer. For winter, you have to add 29, but here you need to subtract 23.5. So get degrees. Okay, so you have to tilt your panel 12.5 degrees for summer if your latitude is 40 degrees. Based on your latitude, the tilting angle changes. Next one for spring and fall, autumn season. So take your latitude and subtract 2.5 degrees. So 40 minus 2.5 for spring and autumn season, 37.5 degrees. Solar panel angle oriented calculation for India. So as already discussed for different seasons. Okay. So sun hours, they are saying sun hours. Sun hours means time spent by the sun in a position that generates peak energy. So that is said to be sun hours. Peak energy, that one only sun hours. Next, top 10 solar panels in 2020 actually. 10th position, dye sensitized solar cells, 11.9 to 12.3% efficiency. So this is the first 10th position. So still more research was going on. Organic solar cells, 15.6 to 17.4%. Cadmium telluride cells, 22.1% efficiency. Polycrystalline efficiency, 22.3 to 22.8%. 2.9 to 23.4%. Unstabilized peroxide cells 23.7 to 25.2%. Then monocrystalline, mostly we are using the monocrystalline. Its efficiency 26.1%. Gallium arsenide cells efficiency 30%. Tantalum peroxide cells 28% efficiency. And topmost one is multi-junction solars. Its efficiency 39.2%. See, so still it is developing stage. If it is coming to market, means we'll get more electricity from solar panels. Actually, how to design your beautiful house with solar? You need to consider 5 things only. If you design these 5 things, then you can install solar power plant in your house, mini solar power plant. So these are 5 points related with your design. First you have to determine the power consumption demands, energy audit like that. Power consumption, how much power consumption by your electrical appliances. Then size the PV modules, photovoltaic module, solar panel module. You have to size how many number of solar panels required for this much power. Then inverter sizing based on the PV models, inverter sizing, then battery sizing. Finally, solar charge controller sizing. So these are the 5 factors considered for your standalone system, not connected to grid actually. This is standalone system. So power demand you have to calculate. So this is the formula for power demand calculation, watt hours, total watt hours. So total appliance watt hours per day times 1.3. Why we are using 1.3 means 130% for extra for compensating losses. So 130% energy lost in system. Then size the PV module. Different size of PV models will produce different amount of power. So size of PV module, climate of site location. So this one, total watt hours per day needed for PV modules divided by 3.43. 3.43 actually a power generation factor. This one changes from site to place to place. For Thailand, they have designed 3.43. So what is the panel generation factor for India and Malaysia? Like that we can calculate. So total watt hours per day needed for PV models divided by that will gives you total watt peak rating for PV panels or your appliances. Then number of panels. So if you divide this total watt hours per divided by 3.43 times rated output peak of PV model. For example, peak PV models rating is 110 watts available. W peak watts available means you have to consider what is available in nearby your places. You can go and collect information from the shops. 110 watt peak means you have to put the value and calculate how many number of panels required for your house. Then comparison of modules. Calculate cost per watt. By cost per watt equal to module price divided by its rated output in watts. Calculate watts per area. Rated output divided by its area gives watts per area. Then inverter sizing. So how do you size your inverter? Inverter size should be 25 to 30% bigger than your total watt of appliances. Then for grid tie system or grid connected system, input rating of should be same as PV array rating to allow for safe and efficient operation. Okay, same rating. Then battery size. Battery actually deep cycle batteries mostly used. And days of autonomy. You have to calculate how many days of autonomy. 2 days of energy required or 3 days you want means you have to put the days of autonomy, 3 days. Total watt hours per day used by appliances times days of autonomy divided by this one, the efficiency of your bed 0.85 and 0.6 times nominal battery. Then that will give battery capacity in ampere hours. Then this depth of discharge. So discharge rating for each battery it differs 95%, 100%, 84%. So for Tesla Powerwall it's 96% depth of discharge. Then finally solar charge controller sizing. So how to size the solar charge controller? Total PV current which is delivered to the controller and depends on PV panel configuration. We can size the controllers. And according to standard practice, solar charge controller rating equal to Total short circuit times 1.3. So this one, the rating of solar charge controller. Short circuit current, actually backside of solar panel they mention the short circuit current. Okay, so you can put 70 means 70 times 1.3. Here also 1.3 is 130% for safety reasons. So here see solar short circuit current is 9.01 amps. So it depends upon your solar panel. It may vary 9.07, 70, 16 like that. So that one, the 5 points for sizing your solar for your standalone system. Your beautiful house, you can design accordingly. Okay. But we have some demerits also. Some demerits since depends upon climate, its efficiency may change. High temperatures can reduce the solar panel efficiency, and panel, if your flat panel means efficiency is not much, and shading also reduces the efficiency of solar panels. Natural efficiency drop. So these are some factors reducing the performance. If you eliminate these factors, means solar is the best choice for future. Okay, so solar panel lifetime is actually 25 to 30 years. 25 to 30 years. So its efficiency will drop about 0.5 to 1% every year after some time. So we can go for solar panels. Okay, thank you very much for your patience. And once again, I thank the organizers and my friends, St. Mother Teresa Engineering College, and also I thank Mahsa University and my friends. Thank you very much. Bye.
Thank you, sir. Thank you. Thank you. Vote of thanks to all. I am very happy to send you the vote of thanks. I thank the Almighty for being with us throughout this session. I express my heartfelt thanks to Professor Rajan, Senior Lecturer of Mahsa University, who cordially accepted our request. We are greatly pleased, sir.
Thank you,
I
sir.
thank management, our chairman, Dr. Babu sir, chairperson, Dr. Amali Babu ma'am, managing director, Mr. Anand Babu sir, for their overwhelming support and guidance. I also extend my thanks to the higher officials of State Group of Institutions. Special thanks to our principal, Professor George Clinton, the head of the department, coordinators, and all the faculty members. I also thank my student participants who are actively involving in all the webinars. Thank you all. Thank you, sir.
Thank you. Sir. Thank you very much.
Thank you. Thank you. Thank you, sir.
Thank you. Bye.
Sir,
Yes, sir.
sir, வீட்டுக்கு பேனல் மாட்டலாம் சொல்றீங்க இல்லையா?
Yes, sir.
அதுக்கு ஒரு அப்ராக்சிமேட்டா எவ்வளவு சார் காஸ்ட் ஆகும்?